geometric word problems. In the next few lectures, we're going to be talking about applied word problems. The first word problem that we're going to deal with is a geometric word problem. Now, a geometric word problem is simply a story problem that involves some type of geometry, either a circle or a rectangle, a square, something geometric, something that we can draw. Let's look at our first example here. The length of a rectangular lot is 6 meters less than 3 times the width. If the perimeter of the lot is 84 meters, find the length and width of the lot. Now we can easily see that this is a geometric problem since we're talking about a rectangle. Okay? Let's first put up some steps for solving these things. And then I'll come back to this problem. There are 6 basic steps for solving any applied word problem. Now you may wish to write these steps down and have them on the side as we're working out this example, and I'll refer to these 6 steps throughout the lecture. But I'll go ahead and read them real quick. The first step is going to be to read the problem carefully and decide what must be found. We'll use a sketch if necessary. Now, in just about every geometric word problem, we'll always be able to do a sketch. Step 2, choose one variable and write down exactly what it represents. Step 3, write an equation using the given information and the variable from step 2. Step 4, solve the equation. Step 5, make sure that you have answered the question of the problem. And step 6, check your answer. Now, let's go back to the problem, and we'll refer to these 6 steps. So here's our problem. Step 1 was to read the problem carefully and decide what must be found. Use a sketch if necessary. Well, let's read the problem. The length of a rectangle is 6 meters less than 3 times the width. The perimeter is 84. Find the length and the width. So I read the problem. Now what must be found? Well, we must find the length and the width. So that's the first step. What do we want to find out of this problem? What is our goal? Well, our goal is to find this length and this width. Now this is an easy problem to sketch. I can even sketch a rectangle, and so I already have done it for us. So I've read the problem. I now know what I need to find. Now I'll go to step 2. Now again, you may want to rewind and go back to those steps, but I will refer to each step as we go along. So here is our rectangle. Here's our sketch. I know that I need to find the length and the width. Step 2 says choose a variable. And this is the important word here. We want to choose one variable that's going to represent each length here. Now, certainly I could say, let's let this be W and this be L, but then I have 2 different variables. So our goal here is to find a variable that describes the width, and we'll find a variable that describes the length. Now, each variable has to be the same, though. Okay, remember, if we look at the problem, it says the length is 6 meters less than 3 times the width. I'll write that down. The length was equal to 6 less than 3 times the width. So why don't we let W equal the width? And I'll write that down. Let W equal the width. Now, how can we represent the length with this variable W? Well, right here it says that my length is 6 less than 3 times the width. So it's 6 less than 3 times the width. And now if we notice, my width is described with W's. My length is also described with W's. So I have chosen one variable, and it represents everything that we need to know. Okay. Step 3. Here is my drawing. I have come up with these two variables here, or two ways to represent our length and our width. Width was w and our length was 3w minus 6. Well, step 3 says to write an equation. Step 4, solve the equation. So let's go back to the original problem. What else did it give us? It says that the perimeter is 84 meters. Well, what does perimeter mean? Well, perimeter is just the distance around. Well, if I've got a w here, then this certainly has to be w. If I have 3w minus 6 here, this is certainly 3w minus 6. So the equation, I have 2w's plus 2 3w's minus 6. And that must equal the total perimeter of 84. Now let's go ahead and solve. 2w, I'll distribute using the distributive property. Let's add these together. These are my like terms. 8w minus 12 equals 84. I can add 12 to both sides. 8w is equal to 96. And if I divide both sides by 8, w is equal to, what's that, 12. So I have solved my equation. So what does that 12 represent? Well, that represents the width. Now, step 5. Let's make sure that we've answered the problem. So far, we've come up with w equals 12. But remember what our problem said. Our problem said find the width and the length. We haven't found the length yet. Well, if our w is equal to 12, and our length is 3 times w minus 6, that means our length must be 3 times 12 minus 6, which is 36 minus 6, or 30. So we've answered the problem. The width equals 12, and the length is equal to 30. Now step 6 is to check our answer using the words of the original problem, not your equation. Well, why is this so special to use the words of the problem, not your equation? Well, if you found an equation that did not make sense to the problem, sure, your answers will satisfy your equation, but if your equation was wrong from the get-go, it's not going to make sense with the original problem. So let's look at what the original problem actually said. The original problem said that our length is 6 less than 3 times the width. So let's see if that's true. Is our length 6 less than 3 times the width? Well, let's see. 3 times the width is 36, minus 6 is 30. So that checks out. And is the perimeter of our rectangle 84? Let's see. 12 plus 12 is 24. 30 plus 30 is 60, and that in fact is 84. So we did check our problem. Now there are several steps, and it can take a long time to get the hang of this, but the more you practice, the better you will be. So make sure you have these steps somewhere in front of you as you attack these geometric problems, and you should have little to no problem after a while.